Hello and welcome, everyone. Thanks for joining us on our LinkedIn Live event today. We'll be talking about EV charging infrastructure, all the power management and software challenges associated with the building or site where you host it, as well as the EV chargers themselves, of course. And we'll talk about practical solutions and be answering your questions too. It's a complex topic, so I'm sure there'll be plenty of them. I'm Angela Swan, and I've been working with my colleagues at Eaton on the launch of our own EV charging infrastructure offer for the past couple of years. So I'll be moderating our session today. Before we get started, a quick reminder that you'll not be asked to click on any links during this event. And if you see me, that's fine. You're in the right place. We certainly welcome your comments and questions, but we'll not be asking you to click on any links, so please don't do that. For those of you joining us today who are not familiar with Eaton, let me tell you a bit more about us. We are an intelligent power management company. We're global. We've got offices and factories around the world, and we've got a very diverse portfolio of products and services. And it's our mission overall to improve everyone's quality of life and our global environment through power management technologies and services. With me today, I have a panel of Eaton colleagues who are all based in Switzerland, and that's where our EV Charging Centre of Excellence is based. So I should say bonjour to them and ask them to introduce themselves. So Delphine, over to you.
Thank you, Angela. Bonjour as well.
Bonjour.
Good morning and good afternoon, everyone. So I'm Delphine Clément. I'm Sales Director for Energy Transition in Europe, Middle East, and Africa. I am an engineer by education. I had several roles in my career, from commodity management, supply chain, to operations, marketing, and I spent a couple of years in my last job as being a segment strategy leader for commercial building. And commercial building sector is very much influenced by energy transition. So very glad to be talking about that today. Fabrice, over to you.
Hi everyone, I'm Fabrice Roudet. I'm the General Manager for Energy Transition in the region. The portfolio of product I'm managing is including EV chargers, energy storage, and the related softwares that will allow to deliver a complete solution for our customers. Eventually, it delivers what we call building as a grid solutions, which is about turning buildings into energy hubs and helping our customers electrifying their fleet. With that, over to you, Firma.
Thanks, Fabrice. So hi, everyone. I'm Firma Manori. I'm based in Switzerland, like my two other colleagues, a little bit more on the mountain side. So this is why my video quality may not be at the best level. Sorry for that in advance. It's pretty stormy today. I hope it's going to be fine. I'm an electrical engineer. I'm very passionate about everything related to the kilowatt hour, and especially the decarbonized kilowatt hour. I work for Eaton as an application engineer for energy storage solutions, electric vehicle charging infrastructures, and energy management software in the C&I segment. So I'm here today to try to answer to most technical questions from the audience. So happy to be here. Again, welcome everyone, and back to you, Angela.
Great, thank you. Thanks. Good to have everyone here today. And thank you for joining us online today. We're delighted to have you here. Please do drop your questions into the comments section and we'll address them in our conversation if we have time. Now, to provide us with a good starting point, I'd like to ask all of you online what you see as the biggest challenges when it comes to thinking about EV charging infrastructure. There are three worries that are mentioned to us quite regularly. The first one is about getting enough power. This is about connections to the grid, really. So if you put in a lot of EV chargers, you may find that the capacity of your building's grid connection is exceeded, and that can be costly. So is this a big worry for you? If so, let us know in the comments. Secondly, choosing the right infrastructure. Are you clear on what type of EV chargers you actually need? So what mix? Are you perhaps puzzling over whether it's best to put in a lot of EV chargers in one go at once, or perhaps phase in the installation? Is working out the best installation strategy a big worry for you? And the big one, the third one, is cost. And a lot of building owners and business owners that we speak to are worried about how much it will cost, not only to install the charging infrastructure, but also how expensive it might be to run it, and the particular concern there about the cost of electricity during the day when prices peak. So in the comments section, those are 3 to get you started off, but let us know your top concern. And if it's not any of these 3, then let us know what's on your mind, and we'll come back to it. We'll certainly come back to all these topics, but we want to know what you think. So while we're finding that out, let me ask the panelists a question to get the conversation started. So, team, in the context of today's difficult economic landscape, why do you believe that building owners and business owners in Europe should press ahead with EV charging infrastructure installation? Wouldn't it perhaps be much better for them to just forget about it and push it back in their business plan to a later date? Should they do that? Delphine, do you want to take that one first?
Yes, thank you, Angela. In fact, the question is whether there is a choice to do it, and the answer I would say is no, at least from a regulatory landscape. So Europe is very active when it comes to pushing regulation related to energy transition. Green Deal set the ambitions to become a carbon neutral continent by 2050. And with that came a very complex legislative package, which is revised on a regular basis. And we see an acceleration in regulation, which are affecting buildings and energy transition. Fit for 55 is the name of this legislative package, which is very important to understand, which sets the ambition of Europe to reduce by 55% the carbon emission by 2030. Out of this legislative package, there are 2 elements that I would like to point out. One, is very much related to building and is called EPBD, Energy Performance of Building Directive. So it's pushing for more energy efficiency. It's pushing for renovation of building to improve the energy efficiency. It also pushes for the integration of energy transition and technologies related to that, renewables, but also EV charging, and not dump EV charging infrastructures, but smart and connected EV charging infrastructures. The second legislative package or legislative or directive I would like to point here is AFIR, Alternative Fuel Infrastructure Regulation, which is more for public charging infrastructures, which is also pushing for a type of charger to be installed and pushing for the deployment of this one. Not without mentioning that EU will also impose a ban on the sale of new combustion engine vehicles by 2035. So combining all of these elements, and back to your question, Angela, it's very important for building owner to understand all of this regulation coming and what it means for them. And again, 2030 is kind of tomorrow, so better to start today to think about what is the right strategy when it comes to integrating EV charger and combining that into an energy transition and decarbonization strategy. Fabrice, maybe you want to add also your point of view on this question.
Yes, obviously, I agree with you, Delphine. And I would say beyond regulations, people who are really deciding are people like you and I. And people are not waiting to buy electric vehicles. The 3 of us here in Switzerland are driving electric vehicles. And now, when you go for shopping or any activities, we are looking at, is there a charger where I'm going? So we are applying pressure on building owners for deploying EV chargers. The numbers are growing fast. We can see growth in almost all countries that are beyond 50% year-over-year sales of electric vehicles. And we see that the share of full electric vehicles is increasing versus plug-in hybrid, so adding pressure on the power distribution of buildings. One of the recent communication of the European Car Manufacturer Association was showing that despite this strong growth, only around 1.5% of the European car fleet was converted to electric, meaning that still big part of the growth is ahead of us. And for that, Bloomberg is forecasting 57 million of electric cars by 2030. So clearly, building owners, they have no choice. We can see today that building owners with a fleet, whatever it's a fleet of commercial vehicles or a fleet of vehicles from employees, they have stronger pressure to deploy chargers, sometimes more than they could from a power distribution standpoint. And this is where we come with solutions enabling it today. So typically combining our chargers with energy storage, with energy management software in order to facilitate the integration of the right number of chargers.
I think you've made both very great points, and I would maybe just add that the building owners actually are really under higher and higher pressure to really reduce the carbon emissions. So installing EV charging infrastructure, for example, or let's call that for short EVCI, because EV charging infrastructure is a little bit long.
That's a good idea.
Let's do that. It's really a great way to reduce carbon emissions, right? So with the right infrastructure, supported also by on-site renewable generation and some kind of energy management software at the building level, EVCI is really preparing the building for the energy transition. We can really think about carbon saving stacking up, both from switching away, for example, from fossil fuel vehicle, right? And because it also becomes possible now to use the electricity that is produced on the building more efficiently. I think, in fact, in terms of, let's say, day-to-day costs, the right charging infrastructure really saves money and reduce carbon emission at the same time. So we should also not forget that EV batteries can at some point be both charging and discharging, right? So bidirectional charging becomes more and more common. EVs can now be used as part of an efficient and low carbon flow between buildings, vehicles, on-site assets like PV on the roof, for example, and at some point also eventually national grids. So I mentioned now carbon reduction, but actually I can also mention energy efficiency here, as we all know that an electric vehicle is way more energy efficient than a traditional car or traditional internal combustion engine car. So, for example, the amount of kilowatt hour that are needed to move from point A to point Z, for example, or to produce work is really greatly reduced. In addition, when we put the energy which comes from a local and renewable source, the benefits are one more time stacking up very efficiently. I could probably talk about that for a very long time, and I think we're probably going to come back on this topic a bit later in this presentation.
Yeah, I'm sure we will. And some great first thoughts from our panel there. Thanks for sharing those. I've just been reading. We've had quite a few answers from our audience, and we're seeing that actually in many ways the three topics that we mentioned right at the top of the conversation, these are sort of concern. So kind of the three that have come to me are basically sort of grid connection, return on investment as well. So it's that cost thing, that's coming through. In fact, yeah, looking at what's come through, the biggest one probably is that cost thing. It's a worry for everyone, I think. With the uncertain global economic headwinds that we're all facing right now, that's a big concern for businesses. So, making the switch to an EV, whether it's domestic or at an enterprise level, it's undoubtedly expensive, as the cost of the vehicles. EVs aren't cheap. And then there are worries about the cost of the EV charger, all of the hardware and the everyday running costs, as we said. So I've actually got a question. Someone in our audience has asked today. It's a bit of a story, actually. They say, I run a business with a small fleet of cars and vans, and I've just started to invest in EVs. But we can't afford to make the entire switch in one go. Our business drivers are each using a home charger at present, but we know that we need to offer some workplace charging so that they can charge at work. And we want to be able to offer visitor charging as well. I'm on this LinkedIn live session today because we don't know where to start and we haven't got a huge budget for this. How can we make a good plan? So I don't know. Fabrice, maybe do you have some thoughts on that?
Yeah, good you mentioned planning because it's really important to minimize cost. So we developed our own tool to design the right solution according to the needs of building owners. We are also working with a company called IES to be able to model the building in order not to focus only on EV chargers, but the overall consumption of the building and the way we can optimize it with our complete portfolio of products. Now, if I take a practical example, here in Switzerland, in our EV charging center of excellence, we started some years ago with just a handful of chargers. and with small AC chargers, because it was what the market was requiring. And guess what? Market has changed. There was more and more need for high-speed chargers, and at the same time, we had our number of employees growing. So we had a combined challenge: increasing consumption of energy coming from our own development and test, and increased energy consumption coming from the number of employees with electric vehicles. So we planned that change in order the infrastructure was right from the beginning, and then adding blocks one by one. So what we did practically was adding 100 kilowatt of solar panels on the roof of the building together with an energy storage system. This allowed us to take less energy from the grid, minimizing our cost. And second thing, we stored energy. And the energy stored allowed us to avoid peak times. And when I say peak times, it's both times where electricity is expensive or times where consuming a lot of energy because all cars are charging and we are performing tests on top of it. So when to control those peak times and when to, I would say, change the behavior of storage, this is where our buildings energy management software is critical. It learns from past days and then decides when to stop or start energy storage, when to minimize potentially the load of the chargers. So it has very complex and powerful algorithms embedded in order all that is performed automatically, ensuring that we are able to optimize our installation on three different criteria: cost, CO2 emissions, and resiliency. And resiliency is very important because, I said before, sometimes you want to have more chargers than you can really afford. So you have to balance the energy and avoid tripping the line. This is exactly what we have put in place here. It allowed us to save a lot of energy. And for people who are concerned, I would say, by payback time, it's fairly short payback time. And additionally, it gives us long-term visibility. So to conclude on that, I would say a well-planned EV charging infrastructure deployment is critical to ensure flexibility in order every components can be added regularly and when it's really required, not necessarily doing full investment at the start. And you'll see after with examples that we successfully deployed it, not only in our own building. So
Hey, yeah,
please go ahead, Angela.
yeah.
I'm
Sorry,
probably too long
yeah.
describing it.
I'm sorry, I was distracted because actually quite a lot of people really interested in the description of of what we've done in Switzerland. Had you got anything more to add, Fabrice, just before I launch into a question? I've just read a really good one here, which I think Fermon might be the person to answer. But anything more to add?
No, just to say, people, they can start small and grow over time. It doesn't have to be big from the beginning, so people not be reluctant to start deploying their EV charging infrastructure.
That's a really good point because as we said, as the first questioner set out, they're starting quite small. So I think that's sort of a really good thing to bear in mind. We will come back to this because I think there's a lot more to say about sort of planning this, but we are getting a lot of questions from the audience, so I do want to take some of those. A question which I think Femon, I think you're well placed to answer this. What are your thoughts and solutions to properly connect to the grid and still keep good power quality in the surroundings? Is the question. What is the effect of having an increase of EV chargers in a grid regarding power quality? So it's power quality sort of question. Is that one okay for you, Femon?
Yeah, sure. And actually, it's a
Sure.
very interesting question, actually.
Yeah.
So, talking about EV chargers and the grid, I think there's two ways of looking at that. EV chargers can be a threat to the grid if we do just plug all the current base of vehicles, if they switch to electric vehicles and we plug all of them into the grid, that is a burden for the electrical grid. No question about it. We can also look at the other side where the EVs and the EV charging infrastructure can actually be a benefit for the grid, right? We see now a more and more penetration of the renewable energies that are by definition not super predictable, not so stable. And this whole new paradigm, I would say, with all those EV chargers taking part actively of the grid, is definitely something that will be helpful for the grid if managed properly. And I mentioned before bidirectional chargers, for example. So this is what we call V2G or V2X, V2H, V2 building. There's a lot of different applications there, but that is definitely something that will need to be part of the electrical grid of tomorrow, let's say. So talking about power quality, for sure, there's going to be some effect, but there's also a very, very good asset that we can now use in order to protect this grid and increase ultimately the penetration of renewable into that general generation mix.
Okay, that question that was from Hector. So thank you for that question. I have another question from. Forgive me if this pronunciation isn't correct, but from Devang. Said, I love hearing about the combination of commercial battery energy storage system plus EVCI plus EMS, so energy management system. Are you able to island the building in the same way that microgrids are? So I don't, who on our panel would like to take that? Is it one for you, Firmin, maybe? Is it one for Fabrice, perhaps?
I can start, and Firmin will correct me if I say something wrong.
I'm listening carefully.
So
Okay.
actually, I would say the combination of storage, chargers, and renewables is already somehow a microgrid application. If we stick to the exact definition of microgrid, it's a system that allows to switch between different sources and perform islanding. In some countries, islanding is required. In some countries, it's not. So if you look at our market in the main countries in Europe, downtimes or times out of energy are very, very limited. So this is not something we are used to offer, but we have in our portfolio a number of solutions, including microgrid controllers that would allow to perform this islanding and run off grid. But in any case, in here, what will be critical is to have a strategy to, I would say, shut down some loads to maximize the time to run on battery or to maximize the energy consumed from solar panels, if any, on the roof of the building. And this is where, again, energy management software is critical to select the right source and do the right dispatching of energy to the right loads.
I'll maybe just add on top of that actually our storage solution in the C&I segment are actually based on UPSs, and Eaton is very, very famous for its UPSs since 40 years or 40 plus years. So we have kept this kind of double conversion, which I'm not going to go into too much details, but that basically means that we have an output plug on the storage device itself, which allows to put loads that are gonna remain, let's say, connected during an outage. So in that sense, I don't know if we can really call that a microgrid, but all the loads, including EV chargers, that you really want at all costs to keep alive when the grid is out. Again, as Fabrice said, it's not in every country that the grid is out twice a day, but if that needs to happen and you still need to feed a couple of loads, that's actually possible with the Eaton X-Storage Compact in that case.
Okay. I can see that time's already moving on. So Delphine, there are plenty of questions coming up for you, I promise. But I'd like to actually talk about the EV chargers themselves as well now. There are questions about those. Choosing the right chargers, it is important, of course, whether you need just one charger or you want to add a lot of chargers to the site so that it's more future ready. However you do this, you really need to make selecting the right combination of EV chargers part of the plan. So let's talk about EV chargers. And I'm sorry I keep asking you, Firmin, but I think you know a lot about the portfolio. So perhaps I could ask you to explain. Would you mind doing that? Thank you.
Yeah, sure. So maybe without going again into too much details, there's really two main ways of charging an electric vehicle. At some point, you have the electrical grid, which is basically alternative current, and you have the battery of your EV, which is basically direct current or DC. You have at some point to convert from AC to DC, and that can happen either in the car itself, in an onboard charging, or in the charger itself. And that's the main difference between AC chargers and DC chargers. DC charging, as we don't have to convert inside the car where we are really limited with, let's say, weight, volume, costs, is usually like way faster than AC chargers. So we usually qualify AC chargers as slow charging devices and DC chargers as fast charging devices. And it's absolutely critical, I would say, that when we plan for a project, we clearly define our needs. Do we have a hospital which needs to charge super fast, an ambulance, or do we have, I don't know, a residential building where actually you have the all night to charge, where an AC charger will be perfectly suitable? But it's really important. And as Fabrice mentioned at the beginning, we have some simulation tools that help actually find the best fit for the use case. Because obviously there's a price difference between a DC charger, which has all the power electronics inside, and the AC charger, which doesn't have all these electronic devices, and obviously is a bit more cost efficient. So I think, yeah, here we can see, we could see actually an example of both AC and DC chargers. So we have on the left, the two black devices are actually AC chargers, so up to 22 kilowatts. And the DC224466 that we see are DC chargers, which goes up to 66 kilowatts, as the name suggests. And maybe just to finish with that, an interesting case is actually about the DC22. So it's 22 kilowatts, and an AC22 is also 22 kilowatts. But as I said, on an AC charger, the conversion is in the car, which means that usually the car itself is limiting the charge. So usually most cars today charge up to something like 11 kilowatts. So by having the same installation, no extra cost, you can charge twice as fast with a DC22 rather than an AC22.
Okay, that was very helpful. It's helpful to see the slide there as well. Could we talk a bit more about software too? I can see that software becomes very important if there's more than one charger. And thinking about, perhaps being in a business, what is the EV and EVCI equivalent of perhaps claiming expenses, if you like, for business mileage, or using a fuel payment card at a conventional filling station? Can you talk me through how all that works from the driver's side and from the business owner's side as well? Perhaps, I don't know who'd like to start. Delphine, would you like to start on that one first?
Yeah, I can make a generic answer, and maybe Fabrice or Femen will want to add on this one, right? So software are absolutely important in this ecosystem because they are the intelligence of the system. And as we have been discussing since the beginning, we can't consider an EV charging strategy without considering the integration of the EV charging infrastructures into the ecosystem. And all of this needs to be connected, right? We have been mentioning building energy management software. So coming back to the charger infrastructure itself, that's the same thing. At some points, chargers are going to be used by EV drivers who could be from a private ownership, residential home, or for public charging. So it will require authentication of user. It will require billing. It will require the charger to be integrated into other third-party system. All of this will be driven by software and by the intelligence, which is either embedded in a charger or in a central software. So again, that's why we have been talking about an ecosystem, and there are different elements in this ecosystem. So maybe Fabrice or Femin, you want to add on that?
Yeah, what I would add to what you said, Delphine, is that there are different tools for different users. In our portfolio, we have Charging Network Manager. This is a software that will be used by the building owner. This is where the building owner will define who are the users who can use the chargers. And this is where the building owner will also define if people would have to pay for the electricity or not. If I take a practical example in our own offices, we have two categories of users: people who are part of the car policy, people who are not part of the car policy. So as part of the policy, you charge for free. Outside of the car policy, you charge at cost. So this is typically what this piece of software would allow for customers having a need to make the chargers available to the public. There are different ways of doing it. One which is becoming, I would say, more and more popular and that avoids intermediaries is what we call scan and charge. So you have a QR code on the charger. As an end user, you scan it and it connects you to I would say, a payment interface where you are going to pay for your charging session. So it avoids having to register to a specific network operator. So it may be a simpler option, particularly when you're on the move and you're not in the region where you live and where you may have a contract with the network operator which has the strongest presence. Last thing is that this is made possible by, I would say, standardization and regulations. And in here, there are a couple of protocols that are critically important. There is one that is quite famous, which is OCPP. That's the protocol used for the chargers to communicate with third-party software. So the more your charger will comply with OCPP requirements, the easier his integration is going to be into third-party software. So that's an effort to be made by all, I would say, EV charger manufacturer in order to facilitate development of this market. And this is something we pay special attention on our side. Firmin, do
That's
you want
also
to
why.
add something?
Yeah, sure. But really bouncing on what you just said, this is also why there are some certification for OCPP, for example, and our, for example, Green Motion building, which is an AC charger, is actually OCPP certified. So all this work which is done upstream, let's say, is going to be less time spent on site trying to integrate with third-party backend system, etc. Because we provide the whole suite of software, but sometimes the customer, for example, already has his own backend system and just want to use the hardware and connect to it. So the fact, as you say, that there are protocol and that we are, for example, certified means that it's going to be not zero work, because there's always a little things to tweak, but it's going to be really facilitated by having this kind of certification.
Okay. Yeah, thank you for that. That's really detailed. And I have to tell you, there are a lot of questions coming in now, actually. We've got Shane from Western Australia with a question, John, Amir. I'm going to come to all of those. I know that we haven't talked much about buildings energy management software yet either, and that's sort of obviously a key. Before we do that, let's perhaps look at if I take them in reverse order, look at Amir's question first. He said, hello, one of the main problems today is providing infrastructure for old homes, apartments, etc. And what's Eaton's solution for that? So this is retrofitting, really. Delphine, is this one for you, perhaps?
Yeah, absolutely.
Okay.
I can take that one. And I think it's a very good question because it's
Mm.
probably more the major part of the use case, right? In many places, a charger will need to be installed in an existing building, an existing home, an existing collective housing, an existing office building. But the issue is that this building has not been designed on an electrical standpoint to accommodate many chargers. And if I want to take the example of the office building where we sit here in Switzerland, we installed two chargers a couple of years ago. And at that time, we have only very limited numbers of EV drivers. Now we are having much more EV drivers, and the impact is really, we see the impact in the electricity consumptions. But more than this is the ability to integrate charger, because it may be limited by the power capacity of the building. So we see a lot of customer coming to us and saying, well, we want to integrate charger. The charger itself is not the issue. The issue is more coming from the power capacity of the building. Will your building have enough power capacity to accommodate charger? And will you choose between charging the car of your employees or your customer, or run your business? Well, it's not the kind of choice that you can make. That's why it's very important to first simulate and plan correctly, right? Understand whether your building will be able to accommodate your charging infrastructure strategy, because again, you may want to start with a couple of charger, but in the future you may want to expand this one. So it's very important to understand and plan correctly and simulate the integration of the charger over time, and the integration of technologies like storage or maybe solar, to avoid expensive grid upgrade, and make sure that you can at the same time charge the car of your employees or your customer, and run your business, right? You don't want to stop your business because you charge car. So
Yeah, sure.
planning is one thing, and it's very important.
Yeah. I think that takes us quite nicely into Shane's question from Australia. He said, grid connection is an issue in Western Australia. Without an additional cost of peak power support via additional batteries or generators, it's actually difficult. And I think that ties up quite nicely with this issue of also the building's energy management software, and that's obviously key to getting the most out of EVCI from the perspective of the building's owner. And I know that ROI was also an issue here, because that's obviously a way to bring on site renewable generation and storage and off-peak energy from the grid into the mix. So slightly jumbled question there, Fabrice, but I know that you love an energy storage system, and for good reason. They're the linchpin of electrification. They're right at the heart of it. So maybe we could have some thoughts on that, Fabrice. Are you able to talk a bit more about the energy management system, perhaps in a building, and addressing Shane's question, this issue of grid connection being an issue in Western Australia? I know it's an issue in Europe too. Is this one
Sure.
that you can pick up?
Yes. So first of all, when we looked at energy management software, we realized that there are very different needs from one building to another. We have a number of buildings in Europe where building owners are not even monitoring their energy consumption. They receive electricity bills, but they don't know how and when they consume energy. So a big part of the energy management software is first to provide information. Why? Because you can only optimize what you measure. That's the first point. The second thing is that in the building, you're going to have more and more controllable loads. So the EMS is going to be the central point of connection for those controllable loads, whatever it's storage, chargers, or I would say HVAC system. And once you have done that, you can start optimizing. And you're going to optimize based on different criteria. So I would say cost of peak power is something which is applying in many locations. And we do have customers with specific electricity contracts, even here in Switzerland, where the price they pay per kilowatt hour on a yearly basis is based on the maximum instantaneous power consumption, which means that potentially the cost of electricity for the full year can be based on a peak that happen once in the year, and that may be as short as 5 minutes. So that's why, having this combination of storage, chargers, renewables, we can flatten the communication, avoid those peaks, and for customers with, I would say, grid constraints, limit it to what the building can take from the grid or what the grid can deliver.
Okay.
Maybe just to add one thing about what Fabrice just said here. So here,
Okay.
you mentioned, Fabrice, like very high price for the instantaneous power that you are reaching, but sometimes it's even above that. Sometimes your DSO will just say, sorry, but my transformer is full. I just cannot put anything extra. So sometimes you pay really high for that. Sometimes it's just impossible. That's where you need some kind of management of the power flows to be able to fulfill actually the needs of the customer or the building owner.
Yeah, for sure. We started to talk quite a lot about sort of, pricing costs. I want to get back to that question about how to make EVCI affordable before we lose track of that. I know that we've talked about planning, but we haven't talked so much about meeting the costs of actually putting the infrastructure in place in the first place. So it's that installation issue. Delphine, is this one that you would perhaps like to pick up on, affordability issue?
Yeah, absolutely. I think it's a very important question, especially in the geopolitics context with rising energy prices and with inflation. So affordability is critical, right? And I may not answer your question directly, but please bear with me. And I would like to talk about the modular approach. Again,
Okay.
as we were discussing before, right, you need to plan for what you will need tomorrow. And your needs may evolve depending on how the EV users connecting to your building will evolve as well. But you need to take that into consideration when you design it properly. That's why planning is important. Plan for the future. And the modularity is also very important. Fabrice was giving at the beginning the example of one of our sites where we had integrated a couple of charger and a couple of energy storage. And that ecosystem combined with solar energy was enough for the use that we had at that time, right? So maybe not too many EV drivers, and we were storing the energy producing on the roof with a part of solar of energy storage. Now, I mean, our charger are almost saturated, so it means there is no room for having more EV users. So we may want to have more charger. We may need to have more energy storage as well to further optimize the self-consumption that we can get from solar, and to also optimize the self-sufficiency that we can have. So again, the modularity of the ecosystem is very important to consider, to optimize the cost. And optimizing the cost meaning, I mean, optimizing self-consumptions and get free solar energy, or drive a strategy which is using a time of use tariff to charge your car or charge your storage when a price of electricity is cheaper if you can't get only solar energy. All of these strategies are very important to put in place to optimize the costs and then have the integration of an EV charging infrastructures affordable.
Okay, well, I can see why you wanted to talk about starting small and scaling up, but I do see in the chat that some people in our audience want to talk about going actually straight to a relatively large scale investment, straight away. So let's do that. And so if you imagine you're a business with the right type and size of grid connection, and you've decided to invest in a lot of chargers supported by on-site generation from solar panels, you want an energy storage system, you want buildings energy management software, that's a big investment. But it may make sense to get that type of EVCI into place in some locations. So perhaps places where a lot of employees and visitors might park together, perhaps universities, hospitals, shopping centres. And there might be situations too where a building or landowner might not have any EVs at all, but they might want to offer EV charging as a service, car parking service. So it makes sense to perhaps go large in these places because the ramp up to having a lot of EVs visiting and parking could happen quite quickly. So how about places like that when we're thinking perhaps of finance, because that's a big investment? I don't know. I don't know if you want to continue with that, Delphine.
Yeah,
Sort of
sure.
how can they finance it?
Absolutely. And I think that's a good question, because investing into large infrastructure, again, it's not just about investing into charger, but also maybe having storage and maybe also considering having solar energy. And then we start to have significant investments. So we have developed a partnership with BNP Paribas leasing services to transform the burden from large investments, so a huge heavy intensive capex required, into opex, and kind of leverage the burden that huge investments can have, and combine this with the revenue that you can get from your charging infrastructures. So moving from capex to opex is one of the things that we can allow for our customer through our partnership and through leasing services. The second element I want to mention in here that we have not been talking enough is that you need to make sure that your ecosystem is also running and is up to time, right? So we also have a large coverage of service across the region to enable and to ensure the operability and the business continuity of the ecosystem. And this can also be embedded into the leasing services. So it's really an ecosystem, and financing the entire ecosystem, which is important.
Okay. Yeah, I mean, I'm just looking here at this issue of cost, and yeah, we haven't talked much about saving money on electricity bills yet, because I know that was an issue as well. Fabrice, those energy storage systems that we were talking about earlier, the energy management system rather, can you talk to us a little bit more about that? sort of, and also perhaps about this grid connection issue a little bit more. Perhaps you might have a project that we've worked on that you could share with us.
Sure. So Firma mentioned in some cases the grid is not even able to provide the energy required. We had a very good customer case that we made public quite recently. So this is the owner of an hotel located in Amsterdam. Actually, initially the building was not an hotel, but he decided to make it an hotel. And the challenge he faced there was the grid connection size. The grid connection was not adequate for running an hotel. So he contacted us asking, okay, do you have a solution for me in order I can run the business I want in this building? So this is typically where we used our simulation tool that allows us to size what could be the energy demand, what would be required in terms of energy generation. So we help the customer in order to properly size solar panels on the roof of the building, combining it with energy storage. And the idea was to reduce, obviously, the consumption during the day with solar when possible. But more important, the objective was to store energy in the batteries in order at peak time, the energy can be taken from the batteries to remain really under the limit of power that can be consumed by the building. So this is what we deployed for this customer. It allowed him obviously to reduce his electricity bill with the installation of solar panels. It allowed him to remain within the limit. And interestingly, because we put it in place, it allowed him to deploy a network of EV chargers. So in this case, it's 9 EV chargers. So it doesn't seem to be a big number for an hotel, but it can represent up to 25% of the energy consumption of the building. So this would not have been possible without deployment of this complete solution. So for building owner, that was, I would say, a perfect solution that we developed for him, saving on energy, remaining compliant in terms of limits. And if I push it further and I look at what could happen in the future, a lot of people are talking about vehicle to grid, vehicle to home, vehicle to building. We can imagine that at peak time, so typically between 6 and 9 p.m., hotel visitors could come, park their car. Their car is not fully discharged, but they are here for the full night. So they could potentially give back energy during this peak time and then slowly, quietly charge during the night in order to be fully charged the next morning at the time to leave the hotel. So this is typically kind of things that we would be able to manage with our energy management system, because if I make it, I would say, if I oversimplify, a car is nothing more than a battery on wheel. So we can manage it the same way we manage our stationary storage. So our EMS analyzes the hotel's current and past energy use trends in order to, and it monitors the weather forecast to ensure that the low cost, low carbon energy from the solar panels is used to maximum effect to reduce the energy bills and the hotel's carbon footprint.
And Fabrice, I cannot comment more on this one. I met the hotel owner 2 days ago. I was in Amsterdam in the Florian Hotel. So this hotel has been running for a couple of months now, and he's very happy about the results. So he came with an issue with the power capacity, and with the entire ecosystem, he can reduce not only the price of the business, of running the business, but also he can reduce the CO2 emission. So he was commenting, was very pleased with that.
Yeah, and I think that where the team that deployed the system is particularly glad is that in this specific case, without this solution, he may even had to close, not having enough power to deliver the business he wants to do.
And just to comment, if I can, I mean, on the impact, I was mentioning business continuity before. You can't choose between charging the EVs or kind of running your business. He had a couple of power shutdowns because of the power capacity, and he was explaining that when resetting the power in the hotel, he had several issues. He had issues with water management. He had issues with connection to the Wi-Fi and to internet, he has issues with the security of the door. So imagine for a hotel not having water, internet, and security is really a major issue. So you can't have any compromise between business continuity for building owner.
Yeah, it's important, isn't it? Yeah. Femma, I think you were trying to get in with a comment there.
Sorry,
No?
Angela?
No,
maybe just to add on that, I think it's what Delphine, you just said now, all of those safety assets that cannot be done basically for a hotel. I would say that in a couple of years, it's going to be even an EV charger is not something that you can have done, right? You have to be able to propose to your guests EV charging solutions, right? Otherwise, your guests are just going to go to the hotel which has something working. So having this grid constraint may seem a little bit a long-term problem, but actually it's not. Right now, it's something you have as an EV driver myself, like you said, also Fabrice. I mean, if I want to go to a place, I want to be sure that the next morning I can actually go back. Especially, if well, maybe not if the place is beautiful, but that's another topic. But
yeah, so sort of basically what we're saying here really is that sort of going for this type of solution, the sort of thing that's happened at the Florian, it's not just a short-term fix. This is something that's for the short term, the medium, and the long term. Really,
I think covers everything.
It's looking ahead.
Absolutely.
You were talking about carbon, and Fabrice, do you know the figure for how much carbon the Florian actually saved?
Yes. So in 22, despite growing energy prices, the Florian kept control of their energy cost. They reduced their carbon emissions by more than 15 tons compared to the average for a building of a similar size. And actually, the carbon saving will help the Florian to reach its corporate sustainability goal of reducing its carbon footprint, and it allows them to be on track towards their objective for net zero.
Yeah, we've still got. I can see that we only have 8 minutes left, and we've still got questions coming in. This is a slight tangent, but John asked a question earlier, and I don't want to just sort of leave it hanging there. He asked, are the amount of charging modes not a bottleneck for customers? That kind of folded in a bit earlier, but is anyone in a position? Femma, you're nodding. Are you able to perhaps comment on John's question?
So hopefully we have standards, right? This is a good start.
Okay.
We have in Europe. So I'm going to talk for Europe because I'm based in Europe. We have, for example, the CCS2 standard. We have actually 4 modes. I'm not going to go into too much details, but basically it goes from just plugging like a toaster your car to something like fast charging on a DC chargers. Obviously, there's a little learning curve. It also started in a very blurry way, right? Like 10 years ago, the standard was not exactly the same. There was a mix. Now it really starts to standardize, at least in Europe. So I would say it's getting clearer and clearer. But of course, the smooth user experience will definitely help in terms of like adoption rate, like being able to be comfortable charging a car. It should not be more complicated than plugging your ICE car, right?
Okay. Yeah. I can see in the questions. Most of the people in our LinkedIn Live today, there are quite a few yet to start developing their EVCI. They're in the early stages. A few are getting stuck with that grid connection thing. We've talked about that quite a lot now. A lot of worrying about the expense. That's back to the pushing back the decision thing, which I know you all said is a bad idea. Something we haven't touched on, Delphine touched on it briefly, is how disruptive it might be to put in EVCI. I know that, I saw this happening actually at my local supermarket recently, and there was a row of parking spaces blocked off for several days to do it. What's the best way around that particular problem? So, avoiding any business disruption. I don't know. Is that who wants to take that, Delphine? Maybe
I can maybe start with this one, right? We have been discussing that a few times already, but it's important to insist. The disruption is not an option, right? We can't have a business being disrupted because he wants to charge the car of its customer or the employee. So it's really very important to consider that in advance with a proper planning. and also with the modularity that we have been discussing before. So make sure that you have the right infrastructure for the need that you have at the precious at that time, but make sure that you are also able to scale over time and to avoid any disruptions in your business.
Okay. This is a great conversation. I can see that we are kind of running quite tight on time now. Before we wrap up, I'd like to ask each of you actually, if everyone involved in our LinkedIn live session today takes away just one thought from our conversation, from our discussion, what should it be? Who'd like to go first with that? Delphine, I know that I've asked you quite a few questions, but do you want to carry on and then we'll
Sure.
Fabrice and
Absolutely.
Yeah.
So thanks.
Okay.
Good question.
Mm.
So if you are planning an investment, and we hope you are, then it's very important to de-risk your investments by doing simulation, by simulating different scenarios, by understanding what is the impact of your strategy into your buildings, or by even fine-tuning your strategy and adapting your strategy to your needs, right? Is it sustainability? Is it compliance? Is it a cost or profit driver? It's very important to simulate to achieve the best results. Why? Because it's complicated. I think you all understand that. So don't think you can simply add a lot of chargers to your building's power management setup and expect it to work seamlessly. It won't.
Yeah, Fabrice, thoughts?
And in here, don't limit your thought process to EV chargers.
Okay.
I mean, maybe you are going to start trying to solve that problem of electrification of cars by considering, okay, how many chargers do I need? Can I put it? But very quickly you realize that it will grow over time. So you need a scalable infrastructure, and scalable infrastructure very often is going to involve flexibility, and the flexibility is coming from energy storage, from energy management software. You may need to reduce your cost, and this can come from on-site solar generation. So my key message would be, even though it's an EV charging need that you have, look at it holistically.
Okay, Femon.
And I think maybe, yeah, really, I cannot agree more with what was just said. Like understanding the right application, the right mix of chargers, like what do I need to fulfill my application, is really, I think, the key. Even if it's scalable, modular, but you need to know what you want to do here. And again, for that, we have put a lot of effort into some tools that help designing, sizing, calculating. I saw in the chat it was mentioned return of investment, CO2 economy, etc., etc. And yeah, for that we have really put a lot of effort into that to really try to be right from day zero.
Okay, thanks so much. I'm going to need to hurry here. We're nearly out of time. I want to thank Delphine, Fabrice, and Femon for a very engaging conversation. I'd like to thank all of you today who've come and joined us online for taking the time to be part of our conversation today, submitting so many great questions, obviously playing an active role. The LinkedIn Live technology means that it's only the four of us on screen, but I know you've been participating together with our own colleagues behind the scenes, who I'd also like to thank. If you've got any more questions about EVCI, we're going to put 2 links in the chat to the EVCI frequently asked questions page and also to the buildings as a grid page. And if I can take you right back to where we started at the top of the hour, these are the only links you should actually click in the comment section. Fabrice spoke earlier about what's been done at our EV Charging Centre of Excellence, where he's based with both Delphine and Femon. So to close, hoping we have time, I'd like to invite you to watch a short video demonstrating what we were able to achieve there. That's where we put in our full Buildings as a Grid ecosystem, and that's what it's called, Buildings as a Grid. It's part of our Everything as a Grid approach to the energy transition. Thank you very much. Thank you very much.